Hey gang, let's get started. To do this simulation, we first got to fire up Visual Studio. So let's go do that and just make sure everything is working, okay? So I've launched Visual Studio 19. I'm going to down and create a new project. Go up to the top up there, make sure that C++ is clicked, and let's not make or let Microsoft help with anything. I want an empty project. Let's go to next. Give it some kind of cool name. I'm going to call mine the ball drop here, and I don't want to store it in repos. I want to store it, say, on the desktop so I can find it quicker. All right, let's go create that. All right, welcome to Windows. Go over to the source file on the right-hand side, add new item, and the new item we want to add is a CPP file. Microsoft always calls it source. We're going to call it main.cpp. All right, let's type in an include statement, include standardio.h. That's the input-output header file for the print statement. Int main, int argc, that's the number of arguments coming in. Character star argv is a vector of arguments. Well, I'll talk about it later. All right, let's just put a print statement in there and see if this thing runs. All right, I hit F5, it ran, everything's good. Let's start over. And this time, let's go do what I did in the last video, but this time in code. So I'm going to set up a y0, make gravity equal to negative 9.8. Don't forget to put the F in there for floating point. Time is 1.6 seconds. Let's write out the math equation. There you go. Maybe I can clean that up a little bit. And let me give it a print statement here. Remember, the %f is for floating point. And put it in the right side of the quote, Scott. There you go. I ran that. Perfect. We got the same answer as in the last video. Well, that wasn't much of a simulation. In a real simulation, you're going to want to watch the balloon drop frame by frame by frame by frame. To accomplish this, let's look at just how fast do video games actually work. Most people will agree that about 60 frames per second is the slowest you'd ever want to go nowadays. Now that's equivalent really to 60, let me write this out, frames in 1 second. So the question I have then is how many seconds does it take between frames? Well, if I take this number here and invert it, I would get 1 second, 60 frames, and that would be seconds per frame. And that equals 0.0167 seconds, which is 16.7 milliseconds. Okay, let's go back to this old equation here. Now, if time in this case is going to be 16 milliseconds, then the position here, y, is going to be how far the balloon has fallen in that short period of time. Now we got a problem. In the next frame, y0 is no longer going to be where I let the balloon go. It's now going to be down just a little bit because it's falling. So in order to fix that, what I could write then is y0 is equal to y. So I'll calculate the position here and then set y0 to be this for the next time around. Now what about v0? v0 has a problem as well. Originally, when I held the balloon up and let go, the original velocity was 0. In fact, we canceled out that whole term. But now I can't do that. Because the balloon has fallen just a little tiny bit, it has now increased its velocity. It's falling faster and faster. So what I'm going to have to do now is every time I loop around, I'm going to have to calculate the new velocity. Well, that turns out to be pretty easy. Velocity is equal to the acceleration of gravity times time. All right? But I'm going to have the same problem here. I got to have VO is going to be the original velocity at the beginning of each frame. So we'll do the same thing that we did here, but I'll say V0 is equal to V, and then we'll just go around and do this again and again and again and again. Now we're talking about a simulation. All right, to save some time, I've typed out the code in advance for you. You can always freeze the video and take a look and copy out all the variables that I've put in here, but let's go back over it again. I'm going to use an include standardIO.h file right up here, and that's going to allow me to use the print statement. I'm going to go into main in a usual way, and now I'm going to set up some variables. This is going to be the new position y. That was the original position y, which was 12.5 meters above the ground. All right. The new velocity is going to be what the original velocity was, but now modified. And originally the ball was moving, or the balloon was moving at 0 meters per second. We've determined that time is going to be 16 milliseconds, or 0.0167 seconds. And the acceleration of gravity, which is in units of meters per second squared, is going to be negative 9.81. Down here, here's the original equation I gave you guys. And then here's the modification. And then here's the new velocity and the new velocity modification. Let's work out our print statement down here and see what happens. Cool. So we're going to, at frame 0, we're at 12.4986 something meters above the ground. And the velocity is negative 0.16 meters per second. That's at the end of the first frame. Cool. So at the end of the 0th frame, the ball had fallen maybe about 1/100th of a meter, and it had a velocity of negative 0.16 meters per second. Now, negative makes sense because the ball is falling down towards the origin, so the velocity is negative. Everything's working out. Let's put this into a loop, but in order to put it in a loop, I got to figure out how big to make that loop. So let's go and do another set of calculations, okay? If the water balloon took 1.6 seconds to strike the ground, and I divide that by the frame rate, which is 0.0167 seconds, what I'll get at the end is 95.8 frames. Let's just round that to 96 frames. And we'll go build a loop. All right, so I'm going to come over here and build a loop for this thing. Let's make right here, we'll build a for loop, for, and let's just go steal this line of code directly and pop it into here. So for int frame counter is equal to 0. Frame counter is less than, let's do 96 frames, all right? And then we'll do a plus plus frame counter. Oops. Frame counter. All right. We'll need an open curlicue brace here, and we'll need another one down here. And there you go. And Microsoft auto-indented for me. How sweet is that? All right. Let's give this a run and see what it looks like. There you go. So after 96 frames, remember that we count 0 counts. So at the end of 96 frames, my Y position has gone from positive 0.154 to negative. I have just crossed over the ground. And at that time, the ball would be traveling around negative 15.6 meters per second in 95 frames. The simulation worked perfectly. All right, so we got that working. Hey, but I got an idea. If you were to put an if statement at the bottom of the loop, inside the loop though, do an if and find out if the Y position is less than 0. If it has, then it struck the ground. If you then took velocity 0 and made the negative of it, it would send the ball back up. It's as if the ball bounced. Hey, cool. We'll get into more of that next time, all right?